Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Data Science and Business Intelligence meeting. So this month, we have Joshua Higginbotham, who's going to talk to us about functional Python. Got the word functional, so of course I'm going to like it. Has the word Python, so of course I'm not going to like it. We'll see what happens. So please, take it away, Joshua.
Thanks, Kevin. Looks like the camera is already frozen, at least on my end. So you'll have to just deal with the freeze frame of my face, I think. So yeah, I'm Joshua Higginbotham. I'm a Microsoft Data Platform MVP, and I currently serve as the Director of Data Engineering at Rev.io. We're an Atlanta-based company. Feel free to follow up with me on LinkedIn if you have any questions about Rev.io. So today's agenda, we're going to kind of go through the slide deck really quickly because we are demo heavy within this session. But if there's any questions that you have, feel free to reach out. We'll try to answer them throughout the session, but ideally we'll answer everything at the end just because we have a lot to kind of move through. But the agenda is we're going to kind of cover some of the approaches to ETL. Depending on your lifespan within IT, you may have worked with multiple ETL type tools, whether it's DTS, SSIS, Informatica's tool, Python, whatever it may be. Kind of go over those. Why did we choose Python as a ETL tool in a prior role that I served under? And then, of course, a huge amount of demos to kind of cover kind of a general basis of what Python can do. It's not the be-all, say-all tool for ETL. I'll repeat this quote later on, but one of the things I will tell people is there's a reason they build different size hammers. So make sure you choose the right size hammer for the right size job. So you choose the right tool for the right job that you have. And we'll kind of have a demo today that kind of covers where Python, at least Python by its core, that's not trying to spin up a Spark cluster or get into Azure or AWS and leverage Spark clusters up there to really hit some of that compute power to get through data set. This is just core Python. If you have any questions after today's demos or the session in general, you can reach me at these locations. My email, I'm getting a little bad at checking my email just because of all the different emails that I have to check. So the best place to hit me up on is Twitter. You can find me at codename Sql. All the source code for this session will be placed out here. If you have any feedback on the session of things that you would like changed or things that you think would make this session better, please feel free to reach out to me through GitHub, open up an issue within that repo and provide that feedback, and I'll try to add it. This session has kind of grown over the last year and is morphed based off of feedback that I've gotten from attendees of these sessions and always find it valuable. So, please provide feedback that you have. So the approaches to ETL. There's, hundreds of tools out there that you can use. There's some that are going to be free. There are going to be some that are going to cost you, your full budget for the year to be able to implement these. And there's not really one tool that I think does greater than most. There's going to be reasons you may want to use SSIS still to this day over using something like Azure Data Factory, Azure Databricks, Python natively, running that locally, whether it's through Apache Airflow or whatever, that you're going to have to just evaluate what's the best approach for your use case. And so when we were looking at the approaches to ETL, and I'm going to preface this before I go into this slide, this is my personal opinion. Feel free to chastise me for my viewpoint, but this is just a personal opinion. This does not reflect what the tool really can do, and there may be others that can improve why this tool does better. But the evaluation was around SSIS because that was our native tool that we were using. Python, because we knew that Python was kind of one of the languages that we would leverage in Azure once we migrated to the cloud. And then we had already started to leverage BIML for some of our solutions that were kind of repeatable approaches. So we were doing loads from a source system, an OLTP system to an OLAP system. And it was the exact same operation across every single table. prior to implementing BIML, we would just copy the container, paste it, go through, modify everything by hand, and that became cumbersome. So we used BIML to do that. But when we were talking about what was the kind of the next phase of our data engineering team, our ETL team, whatever you want to call it at that time, we wanted to make sure that whatever language we went with, whatever tooling we wanted to go with, would be scalable across anything we did. And in SSIS, or sorry, in Azure or AWS, you can of course spin up a VM, install SQL Server integration services, and run your packages without having to do anything. And technically you're in Azure, but it's not the way that we wanted to go. And so again, we looked at BIML, and there's ways. There's Catherine Williamson has a good blog post on how to use BIML and Azure Data Factory. So there's ways to leverage BIML even within the Azure space, but that's a third-party tool. I love BIML. The company that I used to work for, they still have solutions that are running from BIML-based generated SSIS packages. So it's a great tool, but again, we wanted to find that one tool that could help us. And so we went down Python, and that kind of covers the why of Python. We've looked at Python as a language. We knew that we could use it to do data analysis, data science work, and I think that's where Kevin will say there's probably a better language for that, or one that he likes better. But you can also use it for infrastructure as code. So we can spin up Azure Data Factory pipelines with Python. And so, we're able to kind of use this language as a multifunctional tool within our toolbox. And so that was one reason we went through Python as far as that language that we wanted to invest our time in. Part of the reason we went with Python in the end, or we went down the path of trying to do this evaluation, is we had continual failures from metadata changes within our SSIS solution. So something changed either on the source side or the destination side that caused metadata to shift, and now our SSIS packages are failing. And there's ways that you can kind of handle this through SSIS. It's not the best, I think, the best approach to take at times, but there's only so many times that you can tell your senior leadership staff your ETL didn't load overnight because the metadata shifted before they start to get upset with you. You have to kind of build some redundancy, some resilience to your solutions to be able to handle that. And while Python itself suffers from this a little bit as well, it does infer schema if you allow it. There's better checks and balances that you can or different ways you can handle that without having to set certain things in SSIS that would cause you grief later down the road. We needed a reusable code base. So this was big. Kind of like BIML, we needed to be able to basically create a template that would be a set operation and then just kind of clone it off to the side and just plug in a couple of parameters. And then we're off on this new solution. And so, Python being an object-oriented programming language, you could use it for object-oriented programming. This was a good use case. We could create, configuration files. We can use, conditional logic, if else then type stuff, to be able to kind of build this reusable code base, create classes, functions. We could package Python up and allow that to be, sent off to one of the distribution systems to be able to kind of, install that locally so we can use it. So I could build an email handler, distribute that to, the Python distribution area, install that. Now I've got a email handler that will handle all of our emails without having to recode it every single time, basically. And then the other thing was cloud adoption for BI. So in Azure, Python from a BI perspective is leverageable across the full BI space, whether it's Azure Databricks, Azure Data Factory, Azure Synapse Workspace. You can use Python to do this. So this was kind of some of the reasons why we went down Python as a language when we wanted to kind of move away from SSIS over time. So there's a couple libraries that we need to work with when we start talking about ETL. We're going to cover a couple of them today, but there are some out there that are built for for other ththings, whether it's, I think it's called Petal, which is Python ETL. There's a library or a project out there that is, an open source project that somebody is building that kind of facilitates ETL with Python. And so, if you're trying to get major movement up front, you may want to look at a tool like that over building your own custom solutions over time. But the first one that we're going to go over, which is one of the most popular libraries within the Python space, is Pandas. So the Pandas library is used for data analysis and manipulation of data. This is where you're going to start bringing in data into what we consider, or what we call data frames, which is basically an in-memory table, an in-memory like SQL table. It's got columns, it's got rows, it has an index field, and you can sort by things. So it's sitting in memory. Now there's some restrictions there because it is in memory. So, you can't bring in, a terabyte worth of data on your laptop and think you're going to be able to read that. And so there are processes that you're going to have to come up with to account for larger data sets. And this is where Python tends to fall on its face with, is those larger data sets. There are certain operations that are really, really slow, and you're going to see an example of that today, where using Pandas to read data, to write the, certain files is going to be slower than what other file structures may be, or just straight T-SQL. We're going to use it today to read and write from non-structured data and in culmination read structured data. But we'll cover a couple non-structured data files: CSV, Excel, Parquet, and Pickle files. Sql Alchemy is an ORM similar to like Entity Framework. There's a huge documentation space around this, and there's a ton of different connectors that you can use SQL Alchemy with, or database systems that you can use it with. Today we're going to use SQL Server, but there's connectors for MySQL. I think even Cosmos DB you can connect or something like that. But there's a ton of things that you can connect with SQL Alchemy with. And you can just go out to the documentation space and see it. The learning curve with SQL Alchemy is a little tough, especially when you need to do certain operations like insert, update, or delete using the SQL Alchemy ORM to do such. So there is going to be a learning curve, so try to account for that in your planning of all this. And then the last library we use is Pyodbc. It's an open source project that accesses the ODBC-based connections through databases. We're going to use it in conjunction with SQL Alchemy to access our SQL Server. It can be used on its own if the ORM is not ideal. So, if you have talked to your local DBA, most of them will lose their mind if you say the word ORM, just because of some of the ill effects that can occur from code that's generated from ORMs. But again, this kind of goes back to making sure you choose the right tool for the right job that you're working with. So that kind of covers our slide decks. Before we move into demos, does anybody have any questions related to kind of the why we chose Python or some of these libraries that we're working with?
So there haven't been any questions so far, but chat, if you have any questions at all, put them in and we'll get them asked. Especially as Josh was switching over between PowerPoint and Visual Studio Code. But looks like no questions so far.
Okay. So we're going to go through the project real quick, just so if you do go look at the code in GitHub, you'll kind of be able to get around. Some of the stuff is stored through folder structures. Some of this is just for demo-based systems. So obviously my file storage wouldn't be saved within my solution. This would be some network file share that you're reading from or writing to, but for demo sake, we're working with this here. I stored classes under the classes folder, functions under the functions folder, and then any SQL queries that I'm going to leverage in this demo are going to be stored here in a Python file, just as a straight string. And this will make more sense as we get into the code. But this kind of just goes over what you need. For all those, for any dependency that we have, any library that we need, those are stored within a requirements.txt file. See if I can get this to display well. If you go to the project directory and do a pip install -r requirements.txt, what this will do is it'll go through this requirements.txt file and it'll install or upgrade any of your libraries that you don't currently have installed or there's an upgrade available. This is a good way to manage some of those dependencies. You can implicitly set the version of that library in here. That way, if you find that the Pyarrow library has a breaking change from an upgrade, you could hard code to a certain value so you don't bring in that version of it. Again, all this stuff, if you just Google requirements.txt file Python, it'll bring up a good resource on what this is leveraged for. There's other mechanisms to handle dependencies. At the end of the session, and I can send this to Kevin so he can forward it out. I do have a blog post on how to leverage the requirements.txt file and like a SQL agent job to basically install all these dependencies and to run these things on a schedule. The first demo we're going to go into is just connecting to non-structured data. This is a kind of a twofold demo. This kind of shows you how to connect into non-structured data, but it also is a good primer for Jupyter notebooks if you've not worked in them. A Jupyter notebook, you can run these from VS Code, but also in Azure Data Studio. There are SQL notebooks, Python notebooks, and PowerShell notebooks that you can run from there as well. To run a cell, you can click the cell, hit Control Enter. While it's running, you'll see this spinning asterisk, and then once it completes, you'll get a numeric value saying, hey, this ran completely or successfully, and you can move on. So the first thing we're doing is we're importing the Pandas library, aliasing it as PD. So going forward, all I have to do is do pd.function name, and then can run that code. We're then going to create a data frame. So again, I'm going to clear out these results so I'm not showing you prematurely. We're going to create a data frame. So again, this is like an in-memory version of a SQL table. We're going to call the read CSV function from the Pandas library, passing in the file path to that CSV file. So this is within my file storage in directory. And then once we pull that into this data frame, we're going to print the head of this, which is 5 rows by default. You can set this to 10, 15, 20, whatever it is. Or you can do a -5, which will display the last 5 rows. And, again, if you go to the Pandas library or Pandas documentation, you can see some of the stuff. But what this will do is it'll output the first 5 rows of each column to our console. There is a limitation to what can be displayed, and you can set options like display options for Pandas to allow for, full display. So max rows, max columns, but in presentations, that can get a little hard to see everything. So I'm going to leave that off. But one of the cool things about SQL notebooks is once you create a variable or a data frame or a series, whatever you're working with, you can come to this option within the notebook, show variables active in Jupyter kernel. It will give you a list of the variables that have been defined and give you a couple useful information, useful columns about it. What's the variable name? What's the type of that variable? What's the size of it? So how many rows, how many columns in this case of the data frame? And then it'll give you like an excerpt of the values. But if I hit the show variables in data viewer on a data frame, it will display a tabular format of our data frame. So I can come through and review this data. I can filter the data. So if I'm looking at a set value, if I'm wanting to do a little bit of a data profiling, I can do it. And then I can hit this to kind of get back out of it. I can read Excel files just for time, where I'm not going to read this set file. So Excel files, at least just using Pandas, trying to read that is going to be one of those things that's going to take some time. And so the difference between reading this CSV file in a second or two, this could take 2 to 3 minutes sometimes, depending on the size of the file. So again, this kind of goes back to, making sure that you have the right conditions set up for the tool that you're using. Can you change the format that you're receiving? One of the solutions that we worked with in a previous role that I had, the client would send us different formats. So they would send us a CSV version, an Excel version, and a PDF version. And so I was able to choose the format that I was using. So I would read the CSV file, and then I would just archive off the PDF and the Excel file. So always try to evaluate what format that you're going to get. If you can request a set format that's going to work for you as far as performance, try to go for that. A feather file is the same. The syntax is the same. I don't know why the control enter is not working, but it's the exact same file or exact same data set. It's just stored in a different non-structured data. If you have any questions about the different file types, obviously Google them. But one of the biggest things behind certain file types is the ability to compress that data or to partition that data if we're talking about like Parquet files. So depending on how you want to store your data, there's going to be added benefit to that to kind of show you some of those benefits before we kind of move forward. Let's see. Let me get this pulled up first, and then I have to stop sharing my screen and share out this file Explorer window. So these are the files that we were going through and importing into a data frame. Again, these are the exact same data sets, but you can see, dependent on the file type that we chose, the size of that file is vastly different from each other. And so we can see that our CSV file, while like the readability on it's quick, it stores the most amount of data on disk. Whereas our Pickle file is only 627 kilobytes. So depending on what you're trying to do, whether you're trying to create a persistent storage for like archive, so like you may use Parquet files to as a solution for archiving of data. You no longer need to store it in a structured like database, but you want to go to like a semi-structured or non-structured data set. You may be able to use something like Parquet that is partitionable to store your archive data. So if you ever need to leverage or go read it again, you can get to it, but the amount of storage that it takes up is far less. So let's go back into our code. And same thing, we'll read the Parquet file. And one of the benefits, and Pandas does a great job at it, there are times that it fails or falls short on this, is a lot of the functions that you're going to leverage, once you learn some of the syntax or the additional arguments that you need to pass in, a lot of them have those exact same arguments. There are one-offs, like not everything is going to have a compression variable or parameter that you can set. Obviously, the partition columns for Parquet is only unique to the partition or the Parquet functions, but definitely leverage the Pandas documentation area, and I'll show you like kind of a useful landing spot for like getting started that kind of covers how to convert your SQL knowledge to Python, and that's a good like kind of initial building block for trying to learn Python as far as converting from T-SQL to Python. We'll then move into structured data. So again, we've got a Python notebook. We're going to bring in that Pyodbc library that we talked about by importing it. And then we need to define a connection string. So this connection string is similar to what you would see in any other like object-oriented coding language, any connection that you would define within like an ODBC GUI interface. So we're going to define what driver we're using. So we're using the SQL Server driver. We're connecting to the local host SQL Server. We're going to connect to the AdventureWorks Data Warehouse 2017 database. We're using trusted connections, so it's going to inherit my credentials, my user, and then we're going to auto commit any transactions. We're going to then define a query that we're going to use in the SQL call that we make. This is just a string variable that we're defining the full query that we're using. So I'm going to go get every column, and then I'm going to create a order year, order month, and order date column. This will come into play when we talk about partitioning with Parquet. So we'll create the SQL query string. We're then going to connect the SQL server using the Pyodbc function for connect. We have to pass in a source DB config. This asterisk or wildcard, wirecard, whatever you want to call it, what that's doing is just flattening that dictionary out into a flat string for us. So then we can pass that in as a connection string. We then are going to create a data frame calling the pandas.readSQL function, passing in the query and the source connection as the variables, parameters. And we're going to print it to a data frame. Go look at that just to make it a little easier. And we see that we have our data. If I go all the way over, I see my order year, month, and date column. So if I wanted to partition by a certain column, I could do so. Store these values in a ordered by structure or whatever. All right, so then we start to get into functions. So this kind of goes back to code reuse. As I'm developing the solution, I don't want to rewrite code over and over and over again. And so I can generate these functions that will have those reusable code specs to us, or code blocks for us. So within this functions folder, I've got a couple Python files. The first one we're going to look at is the SQL processes. So from this Python file, what we're doing is we're telling it what libraries that we're going to use, and then we're going to define the individual functions that we're going to use within this file. So I've got one for read SQL, write SQL, and then log the SQL. And so I don't have to go out and redefine, all these different, have to recode this every single time I need to read from SQL or write the SQL. By defining this function of read SQL, I've got input parameters of query and connection. Then I create a connection to SQL Server using Sql Alchemy's create engine function, passing in that connection string. I connect to SQL, and then I'm just using that same PD read SQL or Pandas library, but I'm passing in the read SQL query function from that to read that data into a data frame and then move on. And so by creating these functions, what I can do, if I go back to my main extract, I can just simply do a one-liner that says, create this data frame, call the read SQL function from our read SQL function that we created. We're going to pass in the fact cells query, and then here's our connection string that we defined. This connection string that we've defined, you'll see that is stored in the config file, basically. That config file, and we're going to go into one other spot before we go through and we kind of break through this, but it's stored within this config.ini file. So a config.ini file is similar to like a config file that you have in C# solutions or VB.NET solutions. You can define environment.configs. So, if I'm running from the production environment, these are going to be my variable values. If I'm running from the dev environment, these are going to be my variable values. So here I'm just defining what my input paths are, these variables that we'll use as we move through additional demos. But when we get back into our code here, all I'm doing is reading this configuration file and then initializing variables within this file based off of those config settings that we set before. So go grab the connection string from the dev environment and load a variable for the engine connection variable. Same thing, go grab the extract path variable from the dev environment and we're going to create an extract path variable. The difference between these two variables is this section right here, this os.path.join, so forth and so on. So this is not required to be used while you're running this locally, but it does come into play when you deploy this to another system where the working directory is going to be different from where you're running this currently. So by passing in this os path join string, or this function per se, ahead of our configuration, what we're doing is forming, if I can get to it. Let me step through this. We're creating a full string to this file path. So my working directory is C users, Joshua Higginbotham, source repos, whatever. It could be different on the deployed server that I'm sending this script to. And so this is a way of being able to define file paths that are going to work across any environment that you deploy to. And then lastly, we will call our write to CSV function, passing in our cells df and our extract path extract name to output that cells df to a CSV file. And so by doing this, what we're doing is we're basically creating reusable code blocks. So if I go look at the Excel one, there's not much different about the Excel version of this other than I'm calling the write to Excel file. Same thing with Feather. All this is similar. The only difference is I'm calling the write to Feather function from these functions that we defined. We defined here, which is, I didn't cover this, which I apologize, but this is just another Python file that stores functions. So I've got functions created that will read CSV files, Excel files, write to CSV, write to Excel, write to Parquet. And so I can build this out based off conditions that I have. I may have a function. You'll see that I've got two functions here that are for Parquet files. One that is just a general Parquet. I'm going to write the full data set as it currently lives to a singular Parquet file. But then I have this one on line 25 and 26 that I use for partitioning. So I'm telling it I want to partition by certain columns, and I'm going to create a new file for each of those partitioned by columns. And then lastly, we have a Pickle File. Again, this is one of the more compressed files that we saw. We pass in a set compression algorithm. We're using the gzip compression option. There's about 4 or 5 that you can use just out of box without having to install anything else on that system. So definitely look at those before you go out and try to install something not native to your solution. Before we jump into some of the other demos, does anybody have any questions about this? The one thing I didn't cover, which I think may lead to some questions, is this from functions.sql processes import star. So this is how we can basically import these functions or classes or whatever, these structures that we've built out. So what I'm doing here is I'm telling it from the functions folder, we're going to go grab the SQL processes file, and then we're going to import everything underneath it. I could be implicit by what I want to import, so I could do read SQL, or just do wildcard and it'll import everything into use. So this is just how to bring things in. It's kind of like importing namespaces, importing classes within VB.NET or C# or whatever.
Yeah, so we do have a couple of questions. The first one kind of came in just after the buzzer, and that was basically why the use of Python as a language. Was it because of team skills? People already had knowledge with the language, and contrasting this to say using something else like C# to do the same type of ETL?
So it depends on, you kind of bring up a point behind that is you do need to evaluate your team's skill set. You never know where people have come from. I was a .NET developer before I was a DBA. I was a DBA before I became a BI person. And so I knew C#, but nobody else on the team knew C#. So while that's an option, there are plenty of people that go out and build ETL solutions with C#. Python, we kind of jumped towards that mainly because of its ability to be leveraged in some of the Azure solutions that we were looking at, whether it was Synapse Workspace, Azure Databricks, Azure Data Factory, stuff like that. We weren't going to you can't leverage that stuff in those BI architectures or BI systems that we were looking at. So that was kind of the big draw behind why we went with Python. Obviously, you can use other languages. In Databricks, you can use SQL, Scala, Python, I believe R. Kevin, you can correct me. I think you can do R.
Yeah, R is one of the sub languages where not everything's supported. It's Java, Scala, and Python where pretty much everything's supported. R's got its own sub notions.
Yeah, so that was really it. It was more of, part of it was, hey, I want to learn Python. I thought it was cool. I'm going to be honest. I really do like Python. I'm not an expert at it. I'm a journeyman at heart. When I really latch onto something that I really like, I'll build stuff at home. I'll build stuff at work, and we'll build some stuff out. These demos aren't going to go heavy into it. It's not an advanced session, but we were able to build solutions that were competitive with SSIS, and we did this all locally. We didn't use Apache Airflow with Docker containers or anything like that. We created Python scripts. We deployed those, or basically moved these Python files out to a directory on a SQL server, and use a SQL agent job to run the main.py file to execute these ETLs. So you don't have to invest in high-level architecture to be able to work with this stuff locally. So what I'm doing here on my laptop can be done on a SQL server. You just have to install Python on your integration services server that you're using for SSIS now. And there are reasons we would still use SSIS. We wouldn't ever replace SSIS 100% with Python at that point. Just like if we moved to Azure today with everything, you may not use Azure Databricks for everything, or Azure Synapse Workspace. You may use Azure Data Factory. You may use Azure Functions to do certain things that you may not do in other toolings. So, but yeah, it was mainly skill set, and we wanted to learn a new language that was starting to kind of make its prominence within the BI space.
Makes sense. There was a question about PD means pandas, and yes, on line 5. Import pandas as PD.
Yeah. So this is just creating an alias, kind of like you alias a table in SQL Server. So going forward, all I have to do is say PD dot, and then I can select the function that I want to use from that library instead of defining out, pandas dot this every single time. So it's lessening the keystrokes. So.
Yeah, and also because everybody does it, it makes it easy for someone else to look at the code and say, "Oh, PD, that's pandas. Yeah. In P, that's NumPy."
Yep. Yeah, exactly. There are some common. I hate to use the word standards because it's not like you're going to get your hand cut off if you do it a different way, but there are some common standards around aliasing around some of these libraries. So it does help with code readability, as Kevin said.
And the last question here is, I think, one that you're probably going to get to in a little bit, so I'll prime you for it. And that is, so you have SQL queries there, like the fact sales query. What happens if you have, say, an apostrophe in the SQL query? How would we handle that in Python without having to, would we have to escape characters or do anything else special?
Yeah, you would have to do, so I'm not going to get to that in the demo. I could probably work up an example of that and push it to the Git repo as an example. So whoever's asking that question, if you could just ping me through either Twitter or the GitHub repo, I'll be happy to kind of work up a demo on that. But yeah, you are going to deal with some of that, just like you would any other like scripting based language, I guess. So you are going to have to work with like escape characters and all that kind of stuff to kind of get around that. But I'll try to work up an example of that and just send it over and what I would do to get around that. The other option is you can just create stored procedures. So I'm using just straight T-SQL, like ad hoc SQL in here. But if you had like straight stored procedures that do reads from your database, you could definitely use that within Python. So you're not having to put in just straight T-SQL to get around some stuff.
Cool. And the last question here, would you be able to reprise your reasoning behind why going with Python instead of integration services for this work?
So it's not that we were trying to replace integration services. I'm fond of SSIS. And I still teach it to people that are trying to get into SSIS. It's not going away. If mainframe developers show us that you can stay on an older technology and still be pertinent, SSIS is going to be around for well past some of our careers. A lot of the reason why we were going down like Python for ETL was mainly because we were going to go to Azure, and we didn't want to do a lift and shift. And you can use Azure Data Factory to call SSIS, but it's costly. And, right now, if you're a fully on-premises company, like your CFO is probably griping about having to sign for the cost of an ESX host every 3 years, 4 years, whatever you're replacing your hardware for. But it's kind of one of those things that kind of get used to, because it's going to be roughly the same cost every single time, unless, Dell EMC changes their cost, Pure Storage, whatever. But whoever your provider is changes their cost margins or whatever. But when you get up in Azure, you're getting billed for use. And so if every month my bill is fluctuating because I'm running my SSIS solutions differently, or I'm running through bigger loads of data, I'm gonna have to answer for that more and more. And there's a bunch of reasons, but the main one was when we moved to Azure, we wanted to be able to kind of sever our ties from some of those on-premises type tooling. Again, it wasn't going to go completely away, but some of our SSIS solutions were not, true. Like, I hate to use the word true, but they weren't advanced SSIS. All they were orchestration tools. They were calling stored procedure executions in a logical order based off of data warehouse loads, and they were loading the data warehouse all through T-SQL. We were just using SSIS to orchestrate it because all of our data sat on that server through replication. We didn't need to use SSIS to move data from one server to another or do anything like that. So we use SQL to do it. So it just made sense for us to go down this path. Some of it is also the extensibility. So there's a ton of open source libraries that we could leverage that would allow us to connect into things that we just couldn't natively connect through SSIS without having to go pay a company like SentryOne or I can't think of the other one that we looked at for the SSIS tasks that would allow us to connect to, like, say, Salesforce to be able to kind of read data or write to it. So cool.
Great, thanks.
All right, so we'll try to go through some stuff real quick. We're going to jump into some profiling. This is very lightweight profiling. This is not doing true data analysis about our data. This is just kind of show you again how we can leverage Python for multiple different things. So one of the things that I really hound on people about in the BI space is that we don't spend enough time in the analysis phase. we don't look at the data quite enough or at quite the low enough of a grain before we start trying to build stuff off of it or to answer questions off of it. And so one of the best things to do is to profile that data, see what it looks like, massage it as you kind of need. So we're going to import some libraries. You're going to see this a little bit different from some of our other Python notebooks that we've been working with, or Jupyter notebooks. So we're going to import a couple of the libraries that we've worked with. We're going to import that config parser library that we've been using to read our config.ini. And then I'm going to import the functions.sql processes. So because I've built this reusable function, this code function, I can leverage that in a notebook as well. And so I don't have to go through and create new cells for each individual connection string like I showed you how to connect to it all. I can just reuse this stuff. We're going to load our config.ini. Go grab our connection string from the configuration file. Go out and get just all of our sales order header data from our AdventureWorks 2017 database. Load it to a data frame. You can go out and look at that data frame. That should be fun. Go out and look at our data frame. Looks good. I'm already seeing some null values, so we may want to go look at those. I'm seeing a row GUID and a modified date. So I have some things that I can look at for unique values, stuff like that. Get rid of that. We're going to go get our row count. So that's the first thing that I always look at. I just want to get an idea of how many rows are in each. Oh, of course, you can act up. How many non-null values I have in each column, so I can see some of that distribution. So I see I'm already off the top missing some purchase order numbers, salesperson IDs. I've got some credit card IDs that are missing, or they're just not present. Same thing with some currency rates. So I'm just kind of looking at this. I see that, hey, I've got 0 comments. That could be a bug, could be something that we're just not picking up properly. It's just kind of doing that initial look at what our data looks like. I'm going to go get a count of all of our null values or blank values. This should correlate to what we saw above. We see we got purchase order numbers that are missing, credit cards, currency, stuff like that. We see that we're missing all of our comments. That all matches up. And then one of the things that I'm noticing from this is that, again, we have credit card ID that we're missing 1,100 records from. So obviously I'm not gonna make assumptions, but I could evaluate that assumption. So I'm gonna assume that if it's missing the credit card ID field or the credit card approval code, then most likely it was paid with either check or cash. And so to help that case out, what I'm gonna do is I'm going to create a new column called payment method. And I'm gonna use my NumPy library. There's a where function that's similar to a where predicate within T-SQL. So I'm saying where the data frame column credit card ID is null, I'm going to set it to cache, else card is basically what I'm doing. I don't know why it's not working all of a sudden. But now if I go out and I look at our data frame, I see that I've got my payment method card, our payment method column, and I've got some card values in it. So if I go out to our variables list, hit our data frame, I'm going to come out to our payment method. Give this a second to think. All right, so this is kind of a bad example, but I see cash is good when I see the credit fields are null. You can filter this, but for some reason it's not accepting it. I don't know if this broke, but normally you can hit this filter and it'll allow you to type in a value and it'll filter your data frame or this data preview area by it. But I can at least sort. So I see that cash was null in those fields And the ones that are marked card, I see the credit fields are populated. So my new column change went into effect properly. So again, very lightweight data profile, but this does kind of talk about some things. But there is another library that we didn't cover in the slide deck that I did want to talk about. There's this one called Pandas Profiling, and I called this demo profiling data the cool way. Oops. Of course, that's going to act up. Pandas. Here we go. It's called Pandas Profiling. What this will do is it'll generate a HTML document. You can do that. You can store it as like an iframe in the notebook where the profiling report will actually live within this notebook. So if you save it off and share out this notebook, that profile will live in it. To run this profiling, it does take time, especially if your data set is really large. So just give it some time. But what it will generate, and we'll kind of go over the syntax real quick. So we're going to import all of our libraries. If you want some more info about that profiling, I put the link to that library here. We're then going to load our configuration file again, define our connection string, go read from our sales order header table into a data frame. We're then going to define some things about what profile that we're setting. So we're going to use our data frame that we just loaded as our data set. And then we're going to title this report as sales profiling report. And then we're going to run it and we're going to output it to a file in the data profiles directory, call it sales data profile.html. So I've already got this ran because it just takes some time to load. I am going to have to stop sharing my screen so we can show this again.
Okay, while you're switching that over, a quick question. Do you and your team use notebooks for production processes or more for demo and dev work?
It's more for demo and dev work. Obviously, as we would move to Azure, we would start leveraging notebooks for production use. This is going to probably cause a weird loop. Can y'all see the sales profile report before I go back into that?
Yes, the sales profiling report. Yep, it's
showing up now. All right. So in Azure Data Studio, there is a way to create a notebook job, and we did look at doing that. And what that does, and I didn't get to a point where I was comfortable with it in production, but you can create a SQL notebook or a Python notebook in Azure Data Studio and save it as a notebook job. What it does is it creates a table structure to store this in, and then it will run that on a schedule, just like a SQL agent job. And so you could, in theory, use that. I've never tried to do what we did with SQL agent itself by calling like a main.py with like a SQL notebook. But definitely once we started to get into Azure, we started to look at using Azure Databricks. Notebooks became a production thing for us. So, but while we were on premises, yeah, we didn't use it for production, just for data analysis. If we needed to prove, validate logic, prove some, logic that we had, we'd use it. But, so, again, this is kind of why I call it profiling the cool way, because it generates this really nice report. Gives you some general statistics about your data set. The variable types, so these are the data types. So based off of all the columns, we have 12 that are numeric, 8 that are considered categorical, 4 that are date, 1 that's Boolean, and 1's an unsupported data type. So, Pandas does not support all data types. So, I can guarantee that it's that row GUID that is coming off as an unsupported data type. I may be wrong, but I believe that's what it is. This kind of shows you the amount of memory that's being eaten up by this data frame. So it's stored, 6 megabits in memory to be able to hold this data frame. So this could be used to get a gauge of what the data set's going to be once you start doing some production workloads against it. Go down, we can look at all the variables. So these are all the columns within it, and we can see some statistics behind it, some attributes behind it. It has a detail function, so I can, or detail option, so I can toggle this detail to go look at some additional statistics behind it, get a histogram. So it's just a really cool tool if you don't want to go through and build out a common profiling notebook for everything. If you just want to get a general hit of what your data looks like, what's the distribution. So this is one of those categorical columns that we talked about. We see that the distribution is heavy on 8/9. This is just a good way to get a good idea of where your data lives. There's, again, other areas that you can hit. So I can go out and look at our missing values to see, again, we're missing a bunch of our purchase order numbers, our salesperson ID, all of our comments. So it's just displaying that data in a better form. It'll display it in different plotting mechanisms. So like in that notebook, for me to go out and build this, I would have to bring in like matplotlib and to go out and build functions that would plot this stuff out for me. And so they're doing all this heavy lifting for you. So I definitely look at this if you're trying to just do some general profiling. If you worked in Power BI, there's a profiling section within the Power Query editor that has a lot of this stuff. So, if you hand this over to like a Power BI developer, they're going to be able to kind of work with this a bit more. Okay, let's see. Oops.
It looks like, so this report is an Azure Data Studio notebook or the same Jupyter notebook, or how did you?
Yeah, so it's a Jupyter notebook. And so we were able to get that report by importing this Pandas Profiling library. And once we imported that, then we called this, we formed this profile variable based off of the profile report function, passing in the data frame. We're giving our report just a user-friendly title. So then it'll run the profiling. And then once we run it, we can either output it to a file or to like an iframe within the notebook. It does take a while to do, so I don't really want to run this again, but it'll go through, it'll tell you where it's at. So it'll in the console, it will go through and it'll say, I'm, going through and getting the count of records. I'm going through and getting the null value. So you can see it processed, but it does take, for this small of a data set, it takes about 5 to 6 minutes to do. And that's just, I don't want to use up the demos, just waiting for this to complete. But it is a really cool tool. So I definitely would look into it. I'm going to skip around just because I do want to show you where Python falls on its face, or at least Pandas does. So this is reading multiple files, but it also goes into some of the reasons why this could be slow. So again, we're going to import some of the libraries that we've been using across all of our systems. Going to go and connect to our SQL server, or define our connection string for our SQL server. And then I've got within my in directory of my file storage, I've got a bunch of CSV files that are, it's city bike data sets from New York. So it's those bikes that you can go up and rent and ride around for an hour or two and then put them back. And I'm going to loop through that directory. So I'm going through for each file name within that directory. I'm going to go just print out that directory name so I can look at it. So I see that, yep, I'm picking up all these files within this structure. I'm going to create an empty data frame. So then I can iterate through these files and load this to that same singular data frame. And then, yeah, so create the empty data frame, calling it full df. For each file that's within this directory, I'm going to create a file path variable with that individual file name. I'm going to read the CSV file into that data frame. I'm trying to remember what this is called off the top of my head, but it's like a magic command or something like that is what they call it in Python. All this is going to do is it's going to output the time it took to read these files. I'm going to output to console that I'm reading this file. It was this many records, just so I can get a gauge of how much data I'm reading. And then I'm going to load the full DF and to append to a data frame. So I have this existing data frame. I want to write new records to it. I can call the .append function, pushing in the data frame that I'm appending to this existing one. And I'm going to ignore the index, meaning I'm not going to load the index column, the 0, 1, 2, 3, because that would no longer be unique because I'm doing this over and over and over again. So I'm going to load this. We see that we're loading all of our files, nowhere near a second to load each of these individual files. We'll go out and get a shape of this. So we loaded 314,000 records into this data frame in maybe a second or a second and a half. So not slow at all. The read is not bad at all on this. Depending on the size of the data, because this isn't considered big data by any means, you may want to look at having to chunk your data set up. So in the read CSV function within Pandas, there's a chunk size parameter where I can say I'm going to set the chunk size to 5,000. And then you have to build some logic that's going to say, okay, go grab the next 5,000 records over and over and over again to be able to read this data in an incremental fashion, because I can't load it all into this data frame all at once. We're not going to go into that, but again, if you go into the Pandas documentation, you can look up those arguments and then Google what's the best way to use that. Go out and look at our data set. We see that it's really, really clean, which is great. Go out, look at our data. Again, we've got all of our values, so we're good to do something with it. I've got this byte data table that I'm going to use the write SQL function that we built. Again, this is reusing code. I'm actually going to get rid of the time function because it does cause some issues sometimes with the slower stuff. But if I go to write this to SQL, just using this write to SQL function that we created before. So this is using that same one within our SQL processes file that we've been using for some of our smaller data sets. I can see that it's still running. And so it's going to take, I think, hopefully it plays nice on this, but it takes anywhere from 3 to 4 minutes to write this data frame to a SQL table. It's just 314,000 rows. That's not a lot of data, but it's taken 3 to 4 minutes to be able to do it. And so what we can do instead is we can output this data set back to a CSV file. And this seems crazy, but it works. So say you read all these trip data files, you got them into a singular data frame. You go through and you massage your data. You're create new columns that are going to be categorical for your data analysis, whatever. You're going to output it back to CSV into a singular CSV file. And then what we can do, and this is not for production use by any means, this is a lot of hard-coded stuff. But what I'm doing is I'm going to go out, I'm going to create a bulk insert T-SQL statement using Python. So I'm creating this bulk insert to byte data bulk from our file path, which is the location to the CSV file that we're creating off of this full DF data frame that we created through iterating through these files. And then I'm giving it some options around what's the data file type, field terminator, row terminator. The first row starts at 2 and we're going to keep the nulls. So it's just common T-SQL for bulk insert. We'll connect to our SQL server. We'll execute that bulk T-SQL statement, and then we'll close our connection. See, it's still running. So you can kind of see where Python falls on its face a little bit around some of the operations that it has. It does great for bringing data in and you're doing an analysis within Python. What's really great about Python initially for us was we could connect the SQL server once, bring this data into a data frame, disconnect from SQL Server, and then create new data frames based off of the analysis that we were doing. So create a new, just copy the data frame over into a brand new data frame. So I have my original intact. So if I screw up my data in this new data frame, I can just revert back to that old one. So you see that it just finished. So that was, I don't know, 3 or 4 minutes to be able to do it. Whereas, and I'll get back to what I was going at. I do want to finish this demo up. But so we're going to output this to a singular data frame. So that took, maybe a second to do. And then we're going to run our bulk insert statement. Hopefully this doesn't error out. And it ran in maybe 2 to 3 seconds. So, vastly more performant than using the write to SQL function that we created before. And so while we're still using Python to do this, we're just using a different way to do it to be more performant. So, this goes back to that saying that I had. There's a reason they make different sizes of different sizes of hammers. So choose that right hammer for the right job type scenario where we're still staying within Python as our language. We're just leveraging T-SQL to make this process more performant. But what I was getting at with what was really powerful for us initially on was, we'd use Python notebooks, bring data into a data frame, disconnect from SQL Server, and then I could slice and dice my data, do analysis without ever hitting that SQL Server again. Whereas, in some of the earlier phases, we would take down SQL Server by just continually running large queries against data. Or if you're doing an analysis, so you're trying to prove, like you found a bug in the system and you're going through and you're running all these queries to be able to capture what this bug is, how to address it. You can do that in a notebook, save off the notebook, and the result set is saved within it. And so when I go to share that out with my peer that is going to work with me to correct this or to do a peer review, they don't have to go rerun all these queries. They can just pop open the notebook, go review the result set. Yep, I agree. Go ahead and proceed. Or nope, I don't agree. You need to go do this. Instead of having to go rerun those queries against SQL Server, which could be unhealthy at this point, or it could be, an issue if you kind of go forward with it. Cool. So the next thing that we're going to kind of cover before we have this final demo, if we have time, is this main extract Parquet partitioned. So this is leveraging the Parquet file type. It's similar to the main extract files that we showed before. So it's, again, we're importing libraries, or we're bringing in functions or these queries that we've leveraged before. So this queries, that ADW queries, is just, again, one of those string variables that we define the SQL statement that we're going to use. So it's the same SQL statement we saw before, where I'm creating a year column, a month column, and a day column. I'm going to leverage those to partition these files under. Let me get back to this. We're going to give it, and this is a poorly named variable. I just copied the initial script and didn't modify the variable name. This is technically where we're outputting these files to. So this is the folder within our file storage that we're going to be writing all these Parquet files to. We're going to load our configuration file, define our connection string and where we're going to go with this stuff. We're going to read our fact sales query into a sales data frame. And then we're going to define the columns that we're going to partition by. So we're going to partition by order year, then month, then day. And then we're going to call our write to partition Parquet function, passing in our sales data frame, the path to where we're going to store these files, and what columns we're going to partition by. And so hopefully you'll be able to see this kind of run. But what this will create is individual partition folder structures and files based off of those partition columns that we chose before. Oh, come on. There we go. So it creates an order year folder for the first partition of 2010. It creates a month, because right in Visual Studio Code does this. If you only have one singular folder within a hierarchy, it kind of collapses it. So we have another folder for order month 12, another folder for order day 29, and then we have the file, the Parquet file that stores this this partition sector of that Parquet file that stores all the data that have an order year of 12/29/2010. And so if I needed to go back and go grab this data, I only have to go out and read the data from this one structure within this. I don't have to go out and read everything about this. The other thing would be if you're archiving data, instead of having to store this archive data in your SQL server, which is sitting on expensive storage, I could store these store this partition of Parquet files on a slower storage that I could go out and grab this as needed and not have to put that on that really, really expensive storage that we send in front of the CFO every single time to pay for. This is something that you're going to see more in Azure Databricks. Not that everybody is using Parquet files for persisting data within data lakes or within the Databricks file system, but there are people that are leveraging that. That was one thing that we were looking at. And then, of course, we would persist it, in a SQL table at some point based off of what we needed to store. Before we get into the last demo, does anybody have any questions? Okay.
No questions at the moment.
Cool. So the last demo it's not a production query, or a production Python script. A lot of the things that I'm doing within this are not optimal. It's just kind of going over additional syntax. So you kind of see how you can do things, not so much that this is the right way to do it. It's just showing you different ways to like split columns or to rename columns or to drop columns implicitly. So again, like in production, you would do things a little bit more streamlined. So you're not having to use more cycle time to work through this stuff. Just like before, we're going to import either libraries or some of these functions that we've used or classes. We're going to load our configuration file that we're going to read from. We're going to define variables from that configuration file. And then we're going to enter a try-catch block. So just like T-SQL, C#, VB.NET, you have try-catch blocks where I can enter that try-catch. If something happens during that, I go into exception. I can go do something else, finish up the routine, and then get out. We're going to read our CSV file into a data frame called dfbrew. So the data set that we're working with is a brewery data set. We have a column within that data frame called key. And within that key column is a / separated string that stores our country code, state code, and city, as well as our address in one singular string. So I want to split that column out so then I can leverage that, or not leverage that. So then I can write that to a SQL table for use later on instead of having to go through and do this at a later time. Once I split those columns out, I'm going to rename the columns that it creates. So it creates a column, a numeric column, basically, when you do this split. And so what I'm going to do is I'm going to rename the column 0 to country code, 1 to state number, 2 to city, 3 to street address, and I'm going to do an in place, meaning I'm going to rename the columns under the existing data frame that we created, or series. I think it's creating a series at this point. Yep. We're going to convert that key split series into a data frame called dfkey. It does create some bad columns. These are just empty columns because there's some columns that have additional values that we didn't want to use. So we're going to drop those columns. And then we can call our merge statement. And this is a lot all up front. Again, this is just kind of covering different things, different syntax. It's a little common to what you may be using within like T-SQL. So a merge is similar to a join. So we're telling it we're going to join df brew and df key based off of our index value. So we're saying the left index is good to use as our join criteria. Our right index is good to use as our join criteria. So it's like, from df brew join df key on left index equals right index is basically what this is doing. And we're creating a new data frame called results. Then we're going to convert some data types. So again, just like SSIS, it's going to kind of do like a mini profile on your data. And it's going to say, based off of what I'm seeing, I think the data type of this column is a string. And depending on what is being presented to the engine at that time, it may interpret that incorrectly. So we're going to convert the state number column to a numeric value. And then I have a state code CSV file that is from the USPS website that says Kentucky state code is 16. So in a prior role within a company, I worked for a company that did payment processing. We would receive data in multi-forms from payment processors or from these providers. And some would pass us in the chart 2 state code, some would pass us in the numeric, some would pass us the full state number. But within our table structures, we wanted to normalize that. We wanted to have a set standard for how we stored state code. I think that would be most people within the data industry. And so, I could use this state codes list to basically clean up that data. So if I see 01, I'm going to convert that to, Alabama. So I'll bring that into a data frame. And then I'm going to call a transform state, which is just this PD merge, but this is just creating a function that is unique to our state code setup. So if I go to this transformations function file, you see I've got a transform state function, which is just calling that PD merge, but it's specific to this state operation that we're trying to do. So we're saying from the results table, join state codes on state number, and we're doing an inner join. So we're just telling it to do an inner. You can do a left or a right. That's going to be like a left outer or a right outer join. We're then going to create an import date column, setting that value to date time now. So I want to keep track of when we imported these records. So I'm going to create this new column so I can store that value. We're going to remove any columns that we don't need anymore once we've joined this. So we're dropping the key column, state number column, latitude, longitude, and state. We're going to rename some columns. So this is, again, just showing you how to rename this. You'll see that right behind it, I'm dropping some of these columns that we're renaming. This is just to show you the syntax. So if you're looking at this, you can kind of build up that language. So renaming categories to brew category, so forth and so on. We're then going to drop some of these columns that we don't, or so we're going to reorganize our data frame. So I want to reorganize it so it's in the format that it lives within our table structure. That way my insert into this table is a little bit easier to deal with. This also just makes it a lot easier to read. So if I wanted to go out and look at this data frame, I could see it in the logical order that I want to see it. So this is just redefining the order of it. So, it's kind of like when we were in our profiling data, I created this column to store our payment method, but it's storing it at the back end of that data frame. And that may not be optimal if I'm trying to do some analysis within this variables viewer, this data viewer section. So I can reorganize the structure of that data frame within memory and then come back to it at a later time. Once we have it in that structure that we want, I'm going to go out and create a variable for the record count. So I'm calling this shape function, passing in a 0, meaning I want the records, not the columns. That way I could log how much records were in this file that we loaded. And then finally, we'll write it to SQL. If at any point this fails, we'll log to SQL that while we imported the brewery data to SQL, we received an error. We'll log the error message. We're going to hard code it to 0. If we were iterating through that data frame, inserting one record at a time, then we could actually get the rows that we inserted correctly into this variable. But if this was to fail at any point, it would roll back. And so we would not insert any records into it. We'll set the status to 2. Then we pass in the connection string. So I define that a 2 means an error to me in my logging table. We'll then call our error handler. So this is the first class that we're going to cover. And this will kind of finish things up. So I have this error handling class. And I don't go heavy into classes just because there's a lot to cover. But when you're talking code reuse, classes are going to be where it's at. So I define this error handling class. Same thing, I'm going to import some libraries that we're going to leverage within this class. We're going to initialize variables that we're going to use within this error handler class. And then we have one function for our error handling. And as we pass in these variables, we could do if-else logic to evaluate things. This is not production. You know, I don't have an SMTP system set up for me to send emails or anything like that. So this is just kind of a very basic class to kind of show you how you could do this. But basically what this class is going to do is if you pass in a true for log, I'm going to log it to SQL Server. If you pass in true for notify, I'm going to send an email. If you pass in a true for display, I'm going to display it to console. And in C# VB.NET, when I was a like a WinForms developer, built UIs, the display would be what I would display to the user. So there may be errors that you don't want to display to the user. So I would set this to false. So I would get the email and I would get it logged to a SQL table, but the user was unaware that something happened in the back end. So this is just going over conditional if-else logic to do something with it. Oops. And then if it works just fine, we're going to call those exact same functions, the log to SQL. If anything happens, we're going to go to the error handler. This is just there because I know this script won't fail, hopefully. And this is just show you what the output would be. So if I go to, let's see, do I have that extension? Yeah. That way I don't have to go. Nope, I don't have it. Let's see. Cool. So if you don't know, in Visual Studio Code, there is an extension for SQL Server. So you can, from VS Code, go out and query data just fine, which is really cool. So you don't have to jump between like IDEs all the time to work with stuff. So I already have some data in here, so I'm going to get rid of that. Oops, that's fine. I have this file import log, which all it has is a handful of records that we've already loaded just because I was testing this today. So this is just where I'm going to log the results of our load. We'll go back to our script. You can set breakpoints. I know this is kind of late to be talking about this, but just like, in SSIS or C# or VB.NET, I can set a breakpoint and step through things. So we're going to do that. I'm going to set it at our try catch block or the start of our try. Run our Python file. This will go into the debug window. Within this, I can look at current variables just like we showed within that variable viewer, but I can also watch a variable. So if I come in here and type notify it, let's spell that. I can type. I can watch this variable, so I can step through it. And this is common within any of your IDEs, Visual Studio Code. So I'm just going to watch this. So if it ever does change, I can see it change. It's not going to change in this regard, but I did want to show you how you can watch a variable within Visual Studio Code if you do need to debug and see where something changes. So we'll step through this. We get into our split column. So we're going to split off the / column. You see that hovering over that, we're splitting by that. Return to the data frame. We're going to rename these columns. Create a new DF data frame for key based off this key split series that we created. This is just kind of going over all that we went over before. I'm going to hit plus and just step through this, and you'll see at the end of our terminal, when this finishes out, that it's going to output some stuff to console, which it's acting goofy all of a sudden. There we go. So in that class that we defined above for error handling, we said if log was true, print logging it. Else, we're going to say we're not logging it. So forth and so on across these. So we see that the first two that we wrote to console were false. These were defined within our config file right here. So I can come in here. This sits on a directory within our server, and I can change this. So if at any point I need to disable this, I can come into this configuration file and change this. These could also be stored in SQL Server in a configuration table, and you could read these each time the process is ran. So there's no reason that you have to store this in a config.ini. You can use Python just like we're reading SQL to go out and get a config table and set variables off those columns that you read from SQL. This demo is not fully covering, like it's not a covering demo where it's going to cover everything that you're going to see in production. But this is a good kind of place to start at. And then if we go out to our SQL table, just to show you that this did truly work, I'll go query our breweries table again. And we see we've got our data back in our table structure. We see we have our brewery name, brewery category, website, phone number. There's our street address, city, state, country. We see that it's all a chart 2 state code instead of a numeric value or the full Kentucky or Oklahoma that we may have seen before. We see that we have our import date, so we know when these records were imported, stuff like that. Cool. So I'm gonna leave this up just in case anybody has any questions. But that covers it for demos. I know it was a lot to cover. There's probably things that I didn't go too far enough into detail about, but I'm happy to stay around and answer any questions you have or recover anything that I may have kind of blown through a little too quickly. So.
Yeah, thank you so much for that. So got some people in chat saying thank you, including one from a fellow Louisvillian. I don't know the adjectival form of person from Louisville, but
I don't think I know either. Not without butchering it, probably.
In fairness, given that there's like 5 different ways to pronounce the city name itself, there's probably 5 different ways to pronounce a person from the city.
Oh, yeah.
So, folks, if there are any additional questions, please do put them in chat. In the meantime, I did want to say thank you so much for this great presentation. Excellent introduction to Python and how you can use it for ETL processing.
No, appreciate it. Thanks for having me. Actually, that does remind me of something while just looking at this. So another reason we went with Python was unit testing. So natively, you can't really unit test SQL Server. They're sorry, not SQL Server, SSIS. And so And I don't have a demo for this, but we did leverage unit testing within some of these Python solutions that we built. So one of the functions, and this isn't secret by any means, is we had a function that would calculate whether today is a federal holiday or not. So prior to where I work now, I worked in banking. And so there are certain processes that only can run on working business days. So non-holidays, non-weekends. We can't run them on those. And so while the theory is that you create that once, it should never break, but we're reliant on some date dimension that some user built to calculate that, basically, or a table structure, whatever you may have. And there's third-party tools to be able to help you with that kind of stuff, but we relied on a date dimension. We used it in data warehousing. It had whether that was a holiday or not bit flag in it. And so we created a function for that. Then we created a test case on it that would pass in set dates to test our function. And so every time, so within the Test Explorer extension within Visual Studio Code, you can define these test cases. Definitely Google it. Again, I don't have a demo. I apologize for this, but you can set it to every time you save a file within your solution, it will rerun your test. So as I'm making changes, I can do Control S and verify that all my test cases still pass. That way I know that whatever change that I made isn't going to break the core functionality of our program. And then again, these things can be pushed into, I could push this into source control, and in my build and release pipelines, call that test case folder and run automatically all those test cases, spin up a Docker container, install all my dependencies through Python, run the test cases, verify that they pass. If they fail the build, create a bug, we'll go look at it. I couldn't do that in SSIS. We bought SentryOne's Test Explorer, or SentryOne Test, I think is what it's called, to go that path. And then, this isn't a mystery to anybody, but SolarWinds bought out SentryOne. And so around that time, we were moving to Python. And so we kind of abandoned going through SentryOne Test to try to get to unit testing our SSIS. But that was just another added benefit to using Python for ETL, was that we could build our unit tests and our test cases. So, but that, again, you can do that in C#. So that isn't a full answer to that question that somebody had before. But that was one of the things that we found as an added benefit when we started looking at Python.
Excellent. Yeah, that makes a lot of sense to be able to bring in additional testing, especially for something like an ETL process where unit testing is so difficult and even integration testing isn't easy.
Yeah.
Looks like we have no questions from anybody in chat, so I suppose that means you did a fantastic job of explaining everything.
Or put everybody to sleep, either one. So.
We get paid the same either way.
Yeah. Well, cool. Just for a last minute thing, in case, obviously you can reach out to Kevin or Tracy and they can provide this as well, but I'll throw this up one more time. So if you have any questions, definitely try to hit me up through Twitter for all the source code. Give me till about tomorrow morning. I'll push all the changes. I try to go through and comment things that I may have missed before, but if you want to take a look at the code, pull this down. I'll add to the README file. I don't think the README file within the repo has it, but I'll add to the README the command that you need to put in the console to install the dependencies. That way you can run these scripts on your own. But you should be able to run all this stuff on your local machine without having to have anything, because all the files that I work with are stored within that file storage folder structure within the solution, within the stuff that's in source control. None of that's sensitive data by any means. So, but cool. Thanks again for having me.
Of course. And thank you everybody for sticking around. And I'm going to say we'll see you again pretty soon. We are done with meetings for the month of June. We're going to come back in July. I got a full schedule of episodes of Shop Talk as well as our user group meetings. So we'll see you again next month. Until then, everybody, take care and have a good evening.